Hi, welcome to this lecture. In this lecture, I'll show you how you can access and download the Python, the latest Python version 3.7 for this course, and I'll show you how you can download it using the Anaconda platform. So let's get started, okay? First, let's just look at what the latest Python is available. I think it's Python 3.7, and let's go to the main Python website. Here's the main Python website. So that's the latest version, Python 3.7. So this course will be based on Python 3, specifically Python 3.7. You can download the Python version and Jupyter Notebook, but I think what I prefer is just to download the Anaconda platform and install it on your machine. And the beauty of Anaconda is it provides you it installs automatically Python, and it also provides you various data visualization and analysis tools like the Jupyter Notebook and the Seaborn and what have you, right? So let's go to the Anaconda website. Let's just add in another site, Anaconda. I think it's here, anaconda.com. So here, anaconda.com. I'm in the main website here. So what you do is just you find the downloads button on the top right corner here. So go ahead and click downloads, and it will take me to the download page. So at downloading the Anaconda package platform rather. So what is the latest version of the Anaconda that we have? So it's Anaconda 5.3 for Windows installer. So if you have a Mac, you can check this version, Anaconda 5.3 for Mac installers. And if you have a Linux machine, you can check this Anaconda 5.3 for Linux. So Anaconda comes for all of this the three operating systems for Windows, Mac, and Linux. In my case, I have a Windows machine, so I'll just go ahead and download the Windows version. But if you have if you're working on a Mac operating system or Linux, you can do so, right? Just choose the your own version, if it's Windows, Mac, or Linux. Okay, so for now, since I have Windows operating system, I'll just click the Windows version. It's dark black. That's what I selected, and also it shows you here for Windows version. So this is the latest Anaconda. And the other thing that you have to know is it will provide you two options of Python, Python 2.7 version and Python 3.7. So this course is based on the latest Python 3, specifically Python 3.7. So I'll just go ahead and download this latest version of Python. And you can also choose here if your operating system has a 64-bit or 34-bit. You can choose so. So in my case, I have a 64-bit operating system. So I'll just click and download the 64-bit Python the Anaconda with the Python 3.7 version. All right. And as you can see here, Anaconda is downloading. Once this blue circle is complete, my download is done. Then I can go ahead and look at that in the download option. Let me go download. Okay, here. So Anaconda here is just downloaded here, 64-bit 5.3 version. So for you, go ahead and double click this, and it will automatically start installing Anaconda in your machine, right? But because I already have installed Anaconda, let's just go ahead and start opening the Anaconda Navigator, right? So here's just a green, logo or icon here. So Anaconda Navigator. If I click that, the Anaconda window, pops up, right? It's just you have to wait a little bit. It takes time to configure and just load. Okay, so my Anaconda, let me just minimize this. Okay, so this is the my Anaconda, Navigator, right? So as you can see here, the Anaconda Navigator has, various tools, including, the Jupyter Lab and the Jupyter Notebooks. This is the main platform where we will take, this course. This is a Jupyter Notebook where we'll do, Python coding interactively, right? So we'll use this one. But for now, let's just go ahead and check the others. So the IPy, and then the Spider, and Gluvies, Orange 3, and then RStudio, which is a popular data science, open source tool, VS Code. So you have Anaconda comes with, various applications. So in our case, we're going to use the Jupyter Notebook. So let's initiate a Jupyter Notebook, like launch a Jupyter Notebook. This is one approach how you can open a Jupyter Notebook, right? And then I'll show you another way of initiating a Jupyter Notebook. So Python Geospatial, this is my course directory, and it will just take me directly to the code, right? So this is technically an interactive way of writing a Python script and just looking at your results and looking at your maps and plots, which is pretty cool. And then you can also see that this is a Python version here. As you can see, it's Python 3, right? And then you can save your file. So this is just the code, like a Python notebook. And then you can add cells here. You can cut here. You can run. So it's pretty handy. And so let's let's just look at another way of installing a Jupyter Notebook, like this same thing, right? Let me close this. Okay, let me close the Anaconda window, the Python window. So and then let me close the Anaconda Navigator. So without going manually to the Anaconda Navigator, you can open the Jupyter Notebook just programmatically by using a console. Yes. All right. So because I already have Anaconda installed, then I can open the Anaconda prompt here. You can see here it's black. So just if I click that, this is an Anaconda prompt. So anytime you want to install Anaconda like package, like NumPy or pandas and what have you, this is like how you can write a code, installation code, and just run it, and then it will download. But even to open a Jupyter Notebook, I can do that here. So what I'll do is just write Jupyter Notebook, and then if I hit, it will automatically open a Jupyter Notebook. The same thing that I have done manually, right? So it's pretty cool. So every time you want to open a Jupyter Notebook, you can just write it here programmatically. So that's all to what I have to show you how you can download Python with the Anaconda Navigator, and then once you have Anaconda Navigator, you can initiate a Jupyter Notebook to start your coding exercise. All right. In this lecture, we'll be installing the Jupyter Notebook, initiating a Jupyter Notebook using a code prompter, and we will do some exercise on matplotlib to do basic graph. And let's first start. So the first thing you do to start a notebook is just you can definitely use the Anaconda navigator, just if you want to do it manually. And once the Anaconda navigator initiates, you can launch a Jupyter notebook. Okay, so that's kind of a manual way of doing that. And so Anaconda is just configuring and initiating. So once you have the Anaconda navigator, you just launch Jupyter notebook, right? And then you just go to the folder that you have your all scripts. I mean, you can save it in a different location if you want to. So let's get started with the first Python code that we have. So the first thing is, this is just an exercise where we will do some demonstration on how to plot using matplotlib, right? And so this is kind of an interactive platform to code Python. You can create new cells. For example, here, if I just create a new cell here, it will open. And also, if you want to write a code, like for example, import pandas, something like that. So this is just the code, right? And if you want to write a node, you can change here from a code to a markdown, and you can say this is my code, right? And then if you click, it's not running, so it's just a text file. So you can change that here. And then if you want to move this cell, you can just move it up and down. If I want to move it down, I can do that. And I can edit that, just delete that. Even I can delete the entire cell, I can cut that and just delete it. So it's a pretty cool interactive platform for coding. So it's a code editor, but it's interactive. You can add code, you can import data, you can print your intermediate results. You can also plot time series. You can plot maps for geospatial data. So that's kind of an overview of Jupyter notebook. So let's get started with our plotting. So the first thing I'll do is just import matplotlib package and .py plot as plot. So if you want to run a script, so this is our first line, you just go ahead and then do that. If you want to run it line by line, so this is the first line of code, and then if I run that, it's so loading the data with NumPy. And I think, let me just remove this line. Okay, so if there's no issue, it would just keep on running the next one. So and then let's also import pandas as PD, right? But mind you, before we import the data, if in your case you might have problem with when you import the matplotlib and then the pandas, you have to first install this package, right? And once you install it, you can import it. So let me show you how you can install a package for the Jupyter notebook. So let's go to the Anaconda prompt, right? So that's how you install a package. For example, the pandas, right? So to install any Jupyter, any Python package, let me show you. Let's Google it. Install pandas Jupyter notebook, right? So if you just click here, I'm just looking for sample script. like script. Just want to show you how you can get like some codes, or how you can all right, there's not a lot much. Okay, so let's just go back and let's go to the Anaconda prompt, and let's do install the pandas package, right? But I have already installed it. Just but for you, that's how you install it. Let's so conda, right? Conda install pandas. That's the package that you want. If it's a different package, you write so conda install, the name of the package, and just you hit enter. Now it's just active. You see solving environment, so it's attempting to install that. So it's just responding. So this is a line of code that you need to know whenever you have you have to install some package. This is how you install it. All right, on an Anaconda prompt. Okay, so it says that the following package are not available from the current child, but it's already installed. I think that's the reason that it's not letting me do that. Okay, and if your package is not installed, if you run here, you'll just see an error message. If it's not showing you error, then it means that your package is already installed, and then it's importing it, so no issue, right? Okay, this is the first housekeeping that you need to know before you just go in some depths, right? Okay, so run the import, the matplot, and the pandas, and then this is where my data is saved. So I'll define a df pd as a pandas and read CSV. So technically, I'm writing the name of the file. Another thing that I would like to show you is just, you might be interested, where should I put my data and in all my scripts? So where is that? Let's just add another line here. I think it's PW. Let's just try that. Okay. PWD. Okay. All right. Perfect. So PWD is just your working directory for this Jupyter notebook. It will if you write PWD, it will tell you where your just technically your working directory, right? So if I go here, see users, if I go to this file, I'll get all my Anaconda codes and all the input data. That's just my working directory. So let me go to C and users, all my and then Python Geospatial. That's where it is. Okay, so you can see all this, all this. Let's go to the main page. Okay, so you can see all these codes right here, right? You can see all of my Python and codes with IP YNB suffix. So you can see all of these codes, right? And then my data is here. So that's how you write like your data. So this is your working directory. So when you write the file name, you just simply because this is our working directory, we're writing here data LST Brazil. So data LST Brazil. Here's the CSV file. So we're just technically calling this file. So in your case, the first thing you need to know is just to locate your working directory, right? By writing pwd. Once you know your working directory, create a data folder and try to add the data files LST Brazil and put it there, and that's it. And just write this write this script and just run. It should run smoothly, right? That's the first thing you need to know. And then once we imported the data, let's just call. So our data is just df now. So let's select some variables, right? And the other thing is we might be interested to do like df head. Okay, So if you write df head, then you know what the different columns in this database are, right? So I have a months parameter, a year parameter, and an LST and land surface temperature, and a rainfall. This is for Brazil, right? And I would like to map, LST, so I want to select, the different parameters here. So what I'm doing here is just LST is equal to df. This is my data file, and just write the name of the column here, LST, and then value. So it's just selecting that specific column. And then the same thing for rainfall here. And then the same thing for the months and the year, okay? So now it's easy for me to plot each of, these parameters, right? And the next thing is I define my X and Y parameters because I'm doing a, line plot here. So I'm telling so I want my X axis to be months. Here's months, we define that. And then the y-axis is just LST. So, the y-axis is LST, right? And then plot xy. I'm just plotting, LST by months, right? And then just run that. Oh, I have to just run this first. That's why. Okay, perfect. Because I have to run this, this batch of scripts. So now we have made our first, time series plot. So this is, months of the year, and this is land surface temperature values, for Brazil. And this is just a basic, plot. So let's do a little bit of, changing the color and then title and the X and Y axis, right? Let's add some, parameters. Plot xy, and then add plot title. So we're gonna write a title here, Brazil LST. Here is just my title. If I want to change it, it can change. And plot X label. So this is our X label, and then plot Y label. So this is our Y axis. I can change actually LST, all right, or land surface temperature in degrees Celsius. All right, so let's just run this. It should change, right? We have temp here and months here. So when I run the script, it should change, right? So land surface temperature is changing automatically. And then here was 2015 and 2016. Actually, this changed that back to 2015. Okay, perfect. So now we have also changed the color and the type of line. And we have added a title. We have added X and Y axis. That's pretty cool. And let's do this is a line graph, and then let's do a bar plot. So to do a bar plot, instead of PLT plot, we do PLT bar, right? And then XY. So, and then we also just title X and Y label. So if you run this script, it will just give us pretty nice looking bar plot instead of a line. So that's how we can do some plotting using the matplotlib package in Python, a Jupyter Notebook, right? So in this lecture, we'll be looking at how you can generate a time series animation using Python. How can we automate the process using open source Python tool if you have multi-date imagery or satellite imagery, in this case an NDVI, and we'll get that done here. So I'll be using this bit of code. It's available on Git. I'll put the link below, and this is the script that would achieve that. So in this example, I'll use NDVI, normalized difference vegetation index, derived from Landsat image, and I have multiple years of data, and I'll be able to use this code to generate the time series and pretty much well well documented in terms of color bar and title and things like that, and also the different years here to show that kind of animation, year-to-year variation, or various temporal stamp if it's a different data set. Okay, so let's get started. Before I start, I'll just clean everything here so that we can run from scratch. And that's clean. So the first thing is, so this is, as I mentioned earlier, let me just zoom in a little bit so that you can see the code here. So this is NDVI animation with Landsat data. So before we start, actually, let me show you the data set here. And so this is the data set that I'll plan to generate animation. I have multiple years, in this case 3 years. First is NDVI 2017 and the other one is NDVI 2018 and 2019. So I want to show a time series data and using GIF animation, which is pretty cool and powerful to show some temporal variation in your data, right? So this is derived from Landsat satellite. So I'll pull this data and just using this code, and we'll generate a GIF animation. Okay. So these are the different libraries that you need to install. Most of these you can install them using Conda, and all of this, Conda install Imagio and NumPy, Matplotlib, Rasterio, Pandas, and GeoPandas. And then Imagio I'll install it using a pip install here in the Jupyter notebook. Okay, and I've already created my Conda environment. You need to create one if you haven't done so. So you have to install all of this package in a Conda environment, and if you have done so, then let's just get started. So I'll go ahead and then execute this pip install Imagio. It will import actually install the library Imagio, which is powerful to generate GIF or animation, right? And here I have a bunch of libraries that I import. I've already installed all of these libraries using a Conda environment here. So I just need to import them. If you have not done so, just go ahead and install all of this in a Conda environment. And I have I'll execute all of this to import all of the dependencies or just the necessary libraries to execute this animation script. So it has imported all of them, so I don't see any error. And the other thing is I'll set up an environment where I can access my image here. I've shown you already here, right? So I need to copy paste the directory for this so that I can access this raw imagery to generate a time series animation. So I just copy pasted that. You can change this into wherever you put that raster image. And the other thing is this will generate an like a new folder called animation, so that you can store all the animation files. So when I execute this, as you can see here, this is my main directory, and when I execute this, it will create an empty animation folder. Let's just check that. Once we execute this code, it should create animation. Here you go. So we have created that animation folder. So it's empty, as you can see. We don't have any GIF file. So the next step is actually to access all of that image, the file list. You can write this bit of code, and the file name here is TIFF file that ends with TIFF. I can just edit this and save that. So the first thing what it does is just list the TIFF imagery. Let's just go here. So it will just list, we'll go to this folder and list all of the imagery, okay? And then for each image, it will it will actually read that using a rasterio package, okay? And once it reads that, it will generate a plot, okay? All of this bit of code will help us to generate the code, the map, and actually we can plot that. If you just comment this, it will generate that time series. So let me just give you a little bit of description what these guys do. So CMap is a color, yellow-green color. You can change this if you want to, and if you want to reverse the order, you can apply this, or sometimes you can comment that. And this is the dimension of the layout of the plot or the graph, 20 by 15. And finally, this will achieve or execute the plotting. So you're technically using plot image show, IM show. LCPRI is the data, the raster you have already read using rasterio, and then CMap is your color, right? And so I mean you can pull this to a into a reverse, or you can apply this CMap reverse if you want to invert the legend. And now just list the data and generate some sort of title here. You can generate a title to the plot, and some axis, and also some title for the color bar, and actually save the file using the year, in this case 2017, 2018, and 2019, and the NDVI. So let's just first execute this so that we can see some some map here. As you can see here, this is just a gray gray color NDVI image. All right, so this is what we have before we execute that code. Now we are able to generate that time series. If I zoom out a little bit here, we can see this is the time series, and the plot, we have a title here automatically generated, and the color bar here, you can see the color bar, and for all the years, right? So that's the first step. And so we haven't yet implemented, actually let me close this so that we our space is a little cleaner. So as it generates all of the plots, it will automatically generate some sort of monitoring of the output. And if you go to the animation folder, you can see some of this image, right? Let me just make it a little larger. So you can see we have already created this static map layout. If you click here, you can see the the image we have created. Higher NDVI value, lower NDVI value. Of course, it's not visible here, just the background. We'll do that on the dashboard, on the Jupyter Notebook dashboard. So now what the next step is, the next bit of code pulls all of these static maps and then just generates a GIF. Okay, this is where we generate the GIF. So what this function does is that it will pull all of this static image here and sorts them in order and generates a GIF file. Okay, so I'll execute that. Once I do that, we'll have a GIF image here. Let me actually list by detail. You can see all of the static maps are PNG. Once I execute that code, we have this animation NDVI. All right, so let's just click that. You can see we have already created the animation, right? So you have the different years, 2017, 18, and 19. So some spatial variation you can monitor here. I deliberately did like only a few years, but if you have the data set, you can do it like for 10 years or 15 years of temporal variation over space, right? And we have all the legend here, the color bar. So we have already created the GIF animation, okay? And because we have a lot of static data here, let's just clean that. So the next bit of code is it will clean all of these files so that we don't just get confused with the animation file. Okay. So I'll execute the remove function so that we have a cleaner folder here. So we don't have anything. We just have only the GIF animation folder here. That's pretty cool. So we can use this in our presentation and different reporting and things like that. And one of the cool things is that you can also pull this GIF image in a Jupyter Notebook and you can visualize that. So to visualize that, we can execute this bit of code. You'll pull that animation, an NDVI animation file, and displays it here. Just let's execute that in a second. You will display that here. So as you can see here, let's just zoom out a little bit so that you can see the full extent of the animation. So now we have finally generated a pretty cool animation, which has all the title and the legend, the color bar, and which is pretty cool, right? You can automatically generate animation file using a Python script. If you have some sort of image, for example, in this case NDVI, from satellite and whatnot. So this is a pretty cool way to visualize your data using Python and Jupyter Notebook. So in this lecture, we'll be mapping a world population using Python, right? So let's get started. First, let's open a Jupyter Notebook by programmatically using the Anaconda prompt. So to initiate or to open a new Jupyter window, I'll write just the name of the Jupyter Notebook, right? All right, so Jupyter Notebook, if I hit enter, it should automatically pop up a Jupyter Notebook window, right? Okay, excellent. And then here's my exercise and codes are. And all right, here we go. So the first thing first is now you're familiar with the Jupyter Notebook window and the cells and all the buttons and some details. So the first thing is let's import pandas, GeoPandas, and matplotlib. If you have not done so, right? In my case, it's already installed, but just let me show you how you can install it. So the first package is pandas, right? I'll just copy this pandas or just write it here. So go to the Anaconda prompt, open a new Anaconda prompt. So conda install pandas. All right, I'll just hit enter. If it's already installed, it would just tell me so, and if it's not installed, it will install that package, the pandas package, right? So you have to be a little bit patient. It's processing here, and this thing is running. So our required package is already installed, right? So in your case, if it's your first time, then it will just install it, and if it's processing, it will ask you yes or no. You just type Y or yes, and then it will just install it for you, right? So what is the other package? GeoPandas. Let's check that. Conda install GeoPandas, right? Okay. So now I'm installing GeoPandas. Let's check if I already have installed it. It's running, checking GeoPandas package. And if it's not installed, it will install it. If it's already installed, it will just let me so. A little bit patient. All right. So again, so the package is already installed. It's telling me that. So that's how you install. Here the different package that you are importing. Before you import them, just try to install them here on the Anaconda prompt. So now I can minimize or even close, and Now I can just run this cell. Okay, so if it's just going to the next one, it means there's no error, right? And the next step is just to import the, the countries database. Here I saved it in this, file. It's a from natural earth. It's a shape file for different countries. So if you want to put it in the right directory again, you can pwd. This will tell you your working directory for this exercise. So this is your working directory, and in that directory, just go to that directory and then create a data folder, right? So data, and like just open here, paste that directory. Oh, that's just a column. All right. Why is it giving me some error? Okay, it's because of the slash. All right, so this is my working directory. I just got it from here by writing pwd. In your case, it may be different. So just go to that directory and create a folder data, and then put all of your exercise data here in this folder. All right. So once you put those, and so just put all the files. So this is my file, the shape file, NE 110 meter admin countries database. Okay, and let's just go to that folder. So this is exactly what I'm looking for in this exercise. So this is my shape file. Okay, so I'm importing that. So you don't write the entire thing, but just to start from data, and then you already know your working directory. So just copy that and then put it here. All right, and let's run that. Okay, countries. If I print that, so what is found in this shape file, countries admin? The ISO. This is just a 3-letter code for each country, and the name of a country like Afghanistan, Angola, and the continent that that country is found. And pop estimate is a population estimate, which we'll be using later in this lecture to map population of the world, or world population for each country. So now we know that what this shape file contains, and the next step is to plot countries. So the name of the shape file that we imported, and just dot plot. That will give us a pretty cool just basic map of the world countries. But the thing is that, I mean, if you look at this, it's just a single color like blue, and it doesn't provide us any information. It's just basic plot. So what we need is just to find a parameter to do the mapping, and in this case we'll be using the world population estimate. All right, so again you can write countries head, which will again tell you the different columns that you want. So instead of like a default plot, you can define a parameter that you're interested to plot. In this case, I'll just select pop east. That means pop east. So it will plot based on this field or column. So countries plot and column is equal to this. So it will just give me a plot. Here, if I run that, all right. So it's just giving me population of the world was random colors like a blue color, but still then it's just I mean it's good in a way that we're now mapping population estimate. We know that there's something going on here, the yellow, and over here as well, but we don't know the exact amount or just a proportion of or population estimate compared to here. So we still need more detailed information, right? So that's what we're going to do in the next step. So we also, I mean, to do that, we need to import install and import these package. If you have not done so, please do that and just run this package. I think it should be fine. And Then just fig x x is equal to plot subplots, and now we define some parameters. Instead of just the default color choice, we we prefer like equal interval, like quantiles to divide the legend, right? And then we provide the same population estimate data, and then we define the color. You can change here if you want to, and then if you do that, it will give you different color scheme based on the population estimate and provide you the population values. That way it's pretty straightforward to interpret, right? So now we can we have, for example, here, like the yellow colors are the lowest population countries. For example, in Namibia and Botswana fall in this in this first range, and then the deep blue are like highest populated areas like India, China, the United States. So that way we can get or extract information visually by providing some more details to our mapping. That's how you can map features or shapefile using a few packages, including pandas, GeoPandas, matplotlib, and also some additional packages such as the Shapley and geometry. So that's it for this lecture. In this lecture, we'll look at how you can compare different map projections in Python, right? So the first thing first is make sure that you install some package such as NumPy, matplotlib, and also basemap. This is very important for this for this exercise. So you just want to make sure that you go to the Anaconda prompt, or just able to open here on your console Anaconda prompt, and then write Anaconda conda install the name of your package, for example basemap, right? So if you hit enter, that's how you install your package. Once you are done with that, and then run the script. So what we're doing here is just exploring different basemap tool to look at as a background the oceans and the continents in different colors, and in different contrasts, and also different projection to create some nice looking professional maps in Python, right? We're using the matplotlib and basemap, right? So the basemap will give you a background of the map. Like here, as you can see, for example, you have satellite satellite background of the Earth's surface, and also the oceans. And we'll look at different basemap styles, okay, and also different projections. So let's first run this script. So this is just importing the different packages and getting ready. And our first map is that we plot dot figure. So figure size, we can change this the size of the figure, and then we're importing a base map with a projection, so ortho. So that's kind of the ortho view kind of projection. And we can define a resolution, but just we don't need a resolution here. And then the lat long is kind of the focus that we wanna zoom into our map. So just if you click there, this map, you're gonna get this map. And then if you want to change the lat long information, it kind of changes automatically. Like for example, if I look at here, latitude 9, maybe longitude 35, should go somewhere in Africa, right? So you can dynamically change the focus of this map, right? If you change it a little bit, minus then it will just go, below some part below the equator, right? And zoom in into Africa. So you can, you can play with this lat long information, and then the size, for example, if I change this 12, and run that, see, so it's just enlarging. You can increase the size of that map, and then you can focus a different map. It's pretty cool. It's amazing that this base map, package will let you create some, very nice looking, professional maps, right? With an amazing, background. Let's go to another, mapping style. Okay, so here we're just creating, it's LCC. That's the projection style that we're choosing here. Again, we'll plot the size of the map, and then we define the widths, like the width and the height, and just also the lat long information. Here in this example, we'll just focus in Seattle. So we're giving a lat long information in Seattle area, and the beauty is just we can also create some marker, like this marker here, and then we can write a text if you want to, Seattle, and then just run the plot. We can create, like, focus on a certain region of the world, right? And again, I can change this into say, for example, 9, and here longitude information 32, maybe East Africa. I think that's where it is. Let's just try and then run. Fantastic. So that's where, okay, we have to define the where just the markers are. It should match the location of the base map. So this is the longitude 32, and then here is the latitude. All right, let's just create, let's run that and see what's coming. Fantastic. So this is, so you can change, you can play with, these plotting parameters in a base map package. That's amazing. So we can change the location, the lat long information, and then zoom into that area, and then create some markers, and also create some text where that area is. And it's just brilliant, right? Okay, let's go to another one. And then here, let's look at some, map projection. So here, so far, we don't have a latitude and longitude, right? Just, this is just a plain map. But now, what we're doing here is just write a function to create the lat long lines, right? So I'll have here a draw map function. So diff draw map, this is my function. And it has just this input parameter, which is our map technically, and then draw shaded relief image, right? And then it would just create a lat long, the lat longs, minus 90, 90, every, like, this is the difference. So, create a line every certain, units, right? And the longitudes are again the same, just it's minus at 180. This is like the farthest west, and this is the farthest east, right? And then once we have this function that creates a latitude and longitude, let's create different map projections and then see what comes up, right? So the first one is a cylindrical projection. And this just creates a typical, like, the lat long, the lat longs are have a constant gap, like on a straight line, on a horizontal and vertical lines. So this is just what you look at. So here where we're creating is just defining the projection parameter, like a cylindrical projection, and we're defining the the lat long, or just the latitude range and the longitude range, and just draw them up. So draw map is a function that we created where we can create these lines, right? So if we run the script, for some reason it's just draw map. Okay, we haven't run the script, that's why. All right, okay, it's because we have not run this initial script. That's why it's just giving us error. Now it's going good. Like I can run it again, it should be fine, right? Okay. All right, perfect, fantastic. So this is just I think we can change the size of it. Probably 8:6, just proportional. Probably 12:8 plus 410 maybe. Let's just run it. Enlarge. Increase the size a little bit so that we can see. Yeah, that's pretty cool. So this is amazing. We just have satellite background, and also we have this longitudes. With a constant gap, and also the latitude like here, and we have that draw map function, and also we selected a cylindrical function, and we can define the size, like by, for example, I can say the latitude just to be like 10 latitude, the farthest. No, I think that's the south, and this is just north, and also the longitude probably 20 and minus 20. How about that? All right, and we'll have a little bit different zoom level. Okay, you see, I was just falling somewhere that we don't need that. Let's just change this probably -5, and that's the longitude. So how about 35? And okay, let's just run that. All right, it didn't like it. Let's just do how about 5 and 35. Let's do that. Just some part of like Central Africa. Okay, and let's have something like this. Let's have something like this, and 30 over here, right? Okay, hopefully this is our last try just to zoom into Africa. Okay, let's just increase a little bit. -10. All right, we're just experimenting to the lot long gap. So this is like mostly Africa, if not all, right? So we can define the different lot long border lines, and just zoom into any place that we're interested to map. Okay, it's pretty cool. And this is cylindrical, and then we can also do pseudo-cylindrical projection. We just call it here mole, and leave everything as it is, and we can create like a nice looking map, like you see it here. And okay, that's pretty good. And also we can do like some perspective projections, or ortho projection, which can like provide you like some bird's eye view of the globe. Here in this case, we just define ortho here, define some lot long information, especially the Arctic here. You can see the Arctic here. And lastly, let's just do a conic projection. Right here you can define conic projection, and just define a lot long information. Again, here's just Arctic, a little bit slight different version. So overall here in this lecture, what we have done is just try to use the base map and matplotlib to create an amazing map, professional looking map visualizations with different projections and then different background information. and this will help you to create some professional looking maps in Python using especially Matplotlib and the base map package.